Hello and welcome to a new chapter called List Manipulation, and this is the part 1 of this particular chapter. In this part I am going to discuss about the basic introduction to list. So let's get started with the concept of list. So what do we mean by list? List may be defined as a mutable collection of elements of any data type separated by comma and enclosed within square brackets. So what it is a mutable collection of elements. We will come to the concept of mutable soon, but pay attention to these words, mutable and collection of elements. Collection of elements means it is such a data type which can store more than one elements of any data type. Of any data type means whatever elements will be stored within a list, it is not of any single data type. You can have all integers also, all floating points also, all strings also, or a mixture of more than one data type, and we need to enclose it within square brackets. For example, this is an example of a list. Here we have a collection of elements which are 2, 44, 33 and 11, and it is enclosed within square brackets. Now it's not necessary that all the elements within a list will be of the same data type. There can be a mixture of data types also, which we see in this particular example. For example, y equals to 12, Raj and 43.2 is also a collection of elements, but here we have a mixture of data types, but it is a list. How can you identify that a collection of elements is a list and not any other Python object? We can identify with the help of this square brackets. An empty list is created using square bracket, empty square bracket. If I want to create an empty list, then what I can do? I can simply put an empty square brackets. Later on, in that empty square bracket, I can fill it up with elements. But if you want to create an empty list, that can also be done using this process. For example, if I write test equals to empty square bracket, it falls under the concept of list. Now here we noted a very important word called mutable. What is the meaning of the word mutable? Mutable means elements can be changed in place after list creation. Suppose after creating a list, we realize that certain element needs to be changed. Can that be done using list? Yes. In list, even after creation of elements, if we want to change some elements, that can be done. And in Python, this concept where elements can be changed within the same memory location, it is known as the concept of mutability, and those data types are known as mutable data types. In list also that can be done, therefore lists are mutable in nature. How that can be done, we will see in the upcoming slides. For example, if I have this particular list, and from here I want to change the value of 44 to 99, and using the concept of mutability, since lists are mutable, in place of 44 what I can do, I can put 99. How that can be done programmatically, we will see after a few minutes. Next, let us see about the concept of indexing. We already know about the concept of indexing in strings. Similar to the concept of indexing in strings, we have the concept of indexing in list also. Each item in the list consists of a number known as an index. Now, in a list, there can be multiple elements. Each element consists of a number. That number associated with each element is known as an index. For example, let us consider a list x equals to 2, 44, 33, 11 and Bob. Now, how many elements are there in this particular list? We have 5 elements in this list, and each element has a number known as index. If the indexing of a list ranges from 0 to length minus 1 from the left, it is known as forward indexing. Now, if the numbering is done from the left, starting from 0 to length minus 1, what is the length of this particular list? It is 5. Why length is 5? Because we have 5 elements, 1, 2, 3, 4, 5. So if I consider forward indexing, it starts from the left and it starts with 0 to length minus 1. That means it will begin from 0 to 4. So the numbering will be 0, 1, 2, 3 and 4. And this is known as forward indexing. If I have to talk about backward indexing, then it is if the indexing of a list begins from minus 1 to minus length from the right, it is known as backward indexing. So if the indexing begins from minus 1 to minus length from the right, it is known as backward indexing, as you can see in this particular figure. So by backward indexing, the index starts from the right. Therefore, the backward index of Bob is minus 1, backward index of 11 is minus 2, of 33 it is minus 3, of 44 it is minus 4 and of 2 it is minus 5. Therefore, what we can see, of each element we have two indexes, forward index and the backward index. We can use any element, any index for referring a particular element as per our choice. For example, in order to refer 44, we can either use the index 1 or the index minus 4. Both are absolutely fine. Now let us see how do I access the individual elements of a list. The individual elements of a list can be accessed using its index. Just now we learnt about the concept of indexing. So in a list we can have multiple elements. Now if you want to access the element one by one or one particular element from the entire list, then that facility is available. Now how do we access? We access it using its index. For that, a syntax is there. Let's see. The syntax is, we need to specify the list name and then within the square bracket we need to specify the index. Let's try to understand with the help of an example. So for example, if I have a list called X which consists of the elements 11, 22, 33 and Bob, and these are the forward indexes. Now if I want to access 22, I need to access it via its index, that is 1. Now how to access 22? By writing X, which is the list name, and within square bracket I need to specify its index, which is 1. So X1 will give me the result as 22. Alright. So before moving to the next topic, okay, if I want to access the element Bob, how do I do it? X3 simply. So before moving on to the next topic, I would like to show these concepts practically. So how do I create a list? I will take any variable, let's say y equals to, within square brackets I will give certain elements. For example, 11, 22, 33, 44. I can have a mixture of elements like Bob, 5.4, etc. So this is how we create a list. Now in order to access the elements of a list, what we do? We access it via its index. For example, if I have to access 33, now what will be the index of 33? It is 0, 1, 2. So in order to access it, I can give y2 and press the enter key. What am I getting? I am getting the third element, that is 33. If I have to access 33 via its negative index, then it can also be done. How it can be done? Note the negative index here, minus 1, minus 2, minus 3 and minus 4. So if I write y minus 4 and press the enter key, I am getting the negative index. I am accessing 33 itself, but via its negative index, that is minus 4. Now if I write y minus 1, guess the result? Yes, you guessed it right. It will be 5.4. Alright. So elements can be accessed not only by its forward indexing but also by its backward indexing. Now next concept is the concept of mutability of list. A few minutes back we learned about the concept of mutability, what mutability is. Now I will show you how mutability is done. Let us try to implement it and show it. Now what is the current status of our list? This is the current status of our list. Now here, let's say instead of 33, I want to write 99 here. So what I can do here, I can simply do, okay, before going to that, I want to say a concept which is each Python object has a memory location known as its ID. We can view the ID of a Python object by using a function known as ID function. So if I write ID of y, it will give me the memory location of y, which is this one. It's a number. You don't have to remember this number. You just have to pay attention to this number, 4473924608. Now let us try to, what we can do here, we can like in place of 33, I want to put here 99. So for that, it can be done. Yes, it can be done. Why? Because lists are mutable. So how can I do that? I'll give the list name, which is y, and then within bracket I need to specify the index of 33. What is the index of 33? It is 0, 1, 2. So I'll give here y2 and press the enter key. So what it is showing? It is showing me 33. Now in place of 33, I want to put 99. So how it is done? Y2 equals to 99. I'll give that and I'll press the enter key. Done. After that, if I want to see whether in place of 33, 99 has come or not, what I'll do? I'll simply press Y again, and then yes, instead of 33, 99 has been has come. Alright. Now if I check the ID of y after this process, means after changing the value from 33 to 99, let us check the ID. Is it same? Yes, the ID is same. That means in the same memory location, I am changing the value of the elements, and if it can be done, we can say that lists are mutable. Let's take another example, a small example now. Let's say test equals to 9864. In place of 8, let's say I want to give 77. So how it can be done? Test 0, 1, this is the index of 8 is 1, equals to, I want to give what? I want to give 99. No, let's say 77. I'll do that and press the enter key. Now how to check the updated value? By giving the variable test again. So if I give the variable test again, you can see that other elements are same, but instead of 8, 77 has come. This is how mutability of list can be applied. So if you are doing such a problem where the elements may need to be changed at a later point of time, then it's better to use the Python object list. Let's see it again in slides, the concept of mutability of list. We already know that lists are mutable in nature. So for that, let's take an example, x equals to 11, 22, 33 and Bob. Let's see the ID of x, which is, and what we mean by ID? ID means the memory location of an Python object. How do I check the ID of a particular Python object? Using this syntax. I need to put the ID, and within that function I need to put the Python object. Here, which is the Python object? It is stored in the variable x. So I gave here ID x and I got the ID. Now instead of 22, I need to put 99. So what is the index of 22? 0, 1. So what I am doing here, x1 equals to 99. Now if I want to change check the updated list, I'll put the variable x again here, and yes, you can see that 22 got changed to 99. This is a very important concept, so I have done it multiple times so that it becomes absolutely clear to you. Now if I check the ID of x again after this change has happened, then is the ID same or different? Yes, the ID is same. That means in place I have done the modification. In the same memory location I have done the modification. Hence we can say that lists are mutable. Let's move to the next concept, which is accepting a list from the user. Now all of us know how to accept an integer from the user, how to accept a floating point number from the user, and how to accept a string from the user. Now how do we accept a list from the user? For accepting a list also from the user, we have a specific function, which is eval input function. So the eval input function is used in order to accept a list as an input from the user. So if I want to accept integer, the function is int input. For accepting floating point number, function is float input. For accepting strings, the function is input. Similarly, for accepting list, the function is eval input. Let's see the syntax. The syntax goes as follows: variable to hold list equals to eval input, then whatever message we want, we can give the message within quotes. Let's try to understand with the help of an example. So if I write L equals to eval input, enter a list, what it will do, the message enter a list will come and it will wait for the user to enter a list. In that way, we can accept a list from the user. Let me show it to you practically also. So if I take a variable, let's say L equals to, I can take any variable, it's not necessary L every time. Eval input, enter a list. If I do this, if I press the enter key, what message will be displayed? Enter a list will be displayed, and it will wait for me to enter a list. Let's say I'll enter something like 99, 88, 77. I'll enclose it within the square bracket, that is the bracket of the list, and press the enter key. Now how to check whether in place of L this list has come or not? By simply pressing L. If I press L, I am getting the values 99, 88 and 77. That means the list has been accepted. Now why this is a better method as compared to initializing a list directly? Because with this method, every time we run the program, we can put different elements in the list. Okay, let's move on to the next concept, that is traversing a list. Now what is the meaning of the word traversing? Traversing refers to accessing each element of a list one item at a time. If we want to access each element of the list one by one, that concept is known as the concept of traversing. For example, let's consider we have a list. This is the list that we have. Now each element of this list will have an index. Now if I visit each index one after another, that is, at first the index 0 will be visited, that is the element 11, then the index 1, that is the element 22, followed by the index 2, that is the element 33, and finally the index 3, which is the element Bob. So here what I have done, I have visited each and every element of the list one after another. So what I have done in terms of programming, I have done traversing. Alright. Now what we will do, how traversing is done? Traversing is done using the concept of loop. Now what we will do, we will see a program and via that program what we will know, we will know how to traverse a list in Python. Alright. So the next concept is a program to traverse a list using loops. Okay. So for that, what I will do, I'll open a new file. So since I am ready to write a program, I have to go to the script mode. This is the script mode which you are seeing in the screen. If you are not clear with this basic concepts like script mode, you can see my first video on Python, that is getting started with Python. Okay, so let's write this program. Before starting, let me write the name of the program, like write a program in Python to traverse a list. Alright, so first thing that I'll do, I'll accept a list from the user. Let's say L equals to, how to accept a list from the user? Using the eval input function. So eval input, enter a list to traverse. Okay, I'll press the enter key here. After that, let's print it. Print list after traversal. All right, so here now for traversing a list we need the help of loop. Now for I in L, okay, and here what I need to do, I need to print I. Okay, now let me save it. I'll explain this program line by line, don't worry about that. Let's give it some name, save it. Now I'll run the program. So what is coming here? Enter a list to traverse. Let me give any list, let's say 99, 88, 77 and 66, and I'll press the enter key. Now as I press the enter key, you can see that list after traversal, each element of the list is being shown one after another. That means what I am doing here, I am doing the concept of traversal here. Now let us try to understand this program line by line. That means one line at a time. Now what does the first line says? The first line says L equals to eval input enter a list to traverse. So if this is the output screen, what will come in the output screen? Enter a list to traverse. Now what elements have I entered here? I have entered the elements 99, 88, 77 and 66. So the elements I entered are 99, 88, 77 and 66. Now each of the elements will have some index. I am talking about the forward index here. They are 0, 1, 2 and 3. Now this list is stored in some variable. In which variable is it stored? It is stored in the variable L. Let's go to the next line. Next line prints the message print list after traversal. So what we'll get in the output screen? We'll get list after traversal, and then what we have? For I in L, print I. Let's write it here. For I in L, print I. Now what is the meaning of this? For I in L what is stored? 99, 88, 77 and 66. Now loop means it will run continuously until all the values of list are, or all the value of list is traversed. So what will be the first value of I? The first value of I will be 99. So it will take 99 and it will come inside the loop. Now what is the first value of I? It is 99. So what is there within the loop? Print I. So in I what is stored? 99 is stored. So the first value here will be 99. We all know that after printing something, if I use the print function, the cursor moves to the next line. Now since it is a loop and the list is not yet completed, again this line will be executed. But this time the value of I will not be 99, it will be the next element, that is 88. Okay, so it will take up 88 and it will come within the loop. What we have here? Print I. What is the value of I here? The value of I is 88. So 88 will be printed in the output screen. Similarly, this process will continue till all the elements are traversed. Likewise, now the value of I will not even be 88, rather it will be 77. It will take up 77 and it will come within the loop. Print I. What is the current value of I? It is 77. So 77 will be displayed in the output screen. Then it will go to the next value, and that will be the current value of I for I in L. That means the value of I now is 66. It will take 66 and come within the loop. And what we have here? Print I. What is the latest value of I? It is 66, that is the last element. So 66 will be displayed here. Now after 66, do I have any element left? No, I do not have any element left. So the loop will exit and the output will be displayed in the output screen. Now this output I have shown you manually. Let's see whether it matches with our actual Python output or not. So if I show you here, the actual output is 99, 88, 77 and 66 in different lines. Here whatever we have got after traversing it manually, I am also getting the same output. So this is how this particular program is working. I hope this concept is clear. So we have seen a program in Python to traverse a list. Traversing means what? Visiting each element of the list one after another. With this, I have come to the end of the first part. I'll see you again in the next part. Thank you very much.